So in this section, what we're going to look at is right triangle trigonometry. Basically, we're going to look at the trig functions, but we're only going to consider angles between 0 degrees and 90 degrees. You know, in other words, an angle that's in a right triangle that is not a 90-degree angle. That is what we're going to consider here. If you go on into other math courses, like pre-calculus, for instance, you will see how to define the trig functions for angles that are greater than 90 degrees and for angles that are negative. But for now, we're only going to focus on angles between 0 degrees and 90 degrees. Okay, so move up a little. Okay, so here, what we're going to do is this. Let's assume we have a triangle that's a right triangle. And again, all that means is one of the angles is 90 degrees. Keep in mind that if you add up the three angles of any triangle, you have to get 180 degrees. So this angle here is the 90-degree angle. This symbol, which basically is half a square, this is what I'm using to denote the 90-degree angle. And now we have these two other angles here. So what I'm going to use is I'm going to use the Greek letter theta to denote one of the other angles. Namely, I'm going to use this angle. So I'm going to work with this one. So theta is this angle here. Okay, that's good. Now, we have these three sides here, as you can see. What I'm going to do is this. The side that's opposite the 90-degree angle here, that is the hypotenuse denoted by HYP. So HYP, hype, actually, is the length of the hypotenuse, which again is the side opposite the 90-degree angle. For this side here, this is the one that's opposite theta. The length, that's the opposite side. I'm denoting its length by OPP. So again, OPP, that is the length of the side that is opposite theta. So that's what we have here. The remaining side, this side here, this is the side next to theta, adjacent to it. That's the adjacent side. Its length I'm denoting by ADJ. Okay. So we have the three sides here. Let me just say it again. ADJ is the length of the side next to theta, adjacent to theta, that is. OPP is the length of the side opposite theta, and hype is the length of the hypotenuse, which is the side opposite the 90-degree angle. Now, notice also I chose this angle here to represent theta. I could have chosen the other angle instead. The only difference is that opposite and adjacent would essentially interchange. But for now, I'm just going to stick with theta down here. That's really kind of arbitrary. But now we can define these 6 trig functions. We have sine, which is the length of the opposite divided by the length of hypotenuse. Cosine, which is the length of the adjacent divided by the length of the hypotenuse. Tangent, which is the opposite divided by adjacent, and so on. This is actually cosecant. Here we have secant. Here we have cotangent. Now, I know it's a lot to remember. The way people generally remember sine, cosine, and tangent is they use SOHCAHTOA down here. So SOHCAHTOA helps us remember sine, cosine, tangent. Essentially, the O is opposite, the H is hypotenuse, the capital A here is adjacent, and S, of course, is sine, C is cosine, T is tangent, and so on. So we have those three. It actually turns out also, cosine, secant, and cotangent, you can actually express in terms of sine and cosine. Same thing with tangent. And that is what we have up here. We have these identities. You can actually get them easily from the definition. you're expressing, as you can see, cosecant is 1 over sine, secant of theta is 1 over cosine, and so on. And again, you can get these easily using the definition of the trig functions from what we just saw. But this shows that once you know what sine and cosine are, you actually can get all the trig functions. So a lot of the stuff that we're going to do is going to depend on this famous theorem, Pythagorean's theorem. That theorem tells us the following. Suppose you have a right triangle, and C is the length of the hypotenuse. The length of the other two sides are A and B. What this theorem says is A squared plus B squared is equal to C squared. So, and again, we are working with right triangles. So if you went back to our notation from the previous page, so this was, let's say, theta down here. This is the opposite then. This is the adjacent side then. And this is the hypotenuse as before. Pythagorean's theorem tells us that the adjacent side squared plus the opposite side, the length of it squared, equals, see if I can draw this, the hypotenuse, just made it, squared. So it's just really expressing Pythagorean's theorem in terms of our new notation. So that's really what we're doing here.